Don't be afraid, my name is not dangerous at all. I'm also not dangerous. So that's that. I'm from Accurist, and today we're gonna dance together. No, I'm just kidding. Dancing with Moore's Law. So if you have a background in computer science or engineering, you might have heard about Moore's Law. And the mobile cloud disruption that we're calling with Accurist. What is Moore's Law? So just a quick recap. Gordon Moore, one of the co-founders of Intel, he defined this a couple of years ago, this law, or more like a prediction, that the number of transistors on a microchip would double approximately every 2 years, while the cost of computers would be halved. So up until recently, he was very accurate with this prediction, but it's sort of stuck now. And the main reason is physical, so we reached like sizes of atoms when it comes to transistors, and well, I'll leave that up to the physicists to decide what's next. And also effectiveness-wise, when we talk about energy efficiency, another metric is actually much more important. And we're talking about performance per watt, which is sort of considered the new Moore's Law. So you might think, why do we care about that? In a context of Polkadot especially, I'll get to there, don't worry about it. So performance per watt is becoming increasingly more important, and it's effectively just compute efficiency relative to the electricity consumption. Why do we care? Operational expenses. So as we saw in the recent years, also big tech starts to care about costs, fortunately and unfortunately, so there's always two sides of that. And also an ecological aspect. We want to prioritize decarbonization, efficiency, etc. What's the problem? As usual, 66% of the global cloud market is controlled by a few companies. And how do we connect to these issues? So we have like monopolistic pricing that is extracted from everybody who's using cloud providers. I guess lots of people that are building as of today, we have to use them one way or another. And there's a lock-in situation. We have arbitrary charges, intransparent pricing as well. And for me personally, because I have a security background, so for me data ownership, confidentiality is really important. And it's essentially impossible to achieve in a public cloud, especially when it comes to the trust we have to place in these providers. And then last but not least, accessibility. So certain countries are, or whole continents are more or less excluded from certain services. And this is very US-centric, for the good and for the bad. So there's lots of censorship in this regard as well. So this is the issue that we face. And how can we tackle this? So how can we tackle a 66% monopolistic market? Just by changing the rules of the game. And how do we change them? So that's where we close the circle to performance per watt, is by leveraging mobile hardware. Like mobile hardware, these devices are real miracles. They're so efficient. They have high performance. Most of the devices in your pockets can take it up with cloud servers. They're extremely robust and resilient, and have to run for a long time, right? So additionally, what we are also really passionate about is these specific chips that we have on these mobile devices. This is an example of a Google Pixel phone here, where you have TPUs specific for machine learning tasks. We also have high security chips also in iPhones to be found, and other phones as well, where you can store private key material very securely. There's high bounties for these chips, like they're being tested a lot, so definitely special purpose and crafted specifically for these tasks. So these numbers here show that we can actually outperform server hardware heavily. We compare here comparable hardware, so we have a Pixel 7a with 8 gigs of RAM, and we have a Power Edge server that also has the same CPU more or less and same RAM capacity. And you can see already the price of acquisition is 6 times cheaper, and we're talking about a new device here, so if you go second hand or even upcycling, it can be lower and lower. If we compare CPU mark, it's even outperforming the server. And if we go performance per watt, so the energy cost at the end of the day is 50 times less. So that's when we say we change the rule of the game. This is how we change it. The 83 times improvement there, you might wonder this is a mistake, but no, it's not. So if you actually use like a specific GPU from a specific device or TPU and have like a task defined that is optimized for this kind of chip, then you can achieve up to 83 times performance gains. So this is like huge, especially when you consider that these devices are also highly secure. Why upcycling? So we have all of these devices that are not being used anymore by telco providers. I just heard today a story of a huge consulting firm in New York. They're replacing these their phones every few years, and so they're just returning them, or God knows what they're doing with these phones. They're just maybe landing on a landfill or just in a drawer unused. So there's huge untapped opportunity here for us. We already saw, we're based in Switzerland, that like people start buying together these broken screens or phones with broken screens and start to upcycle them already. So this is already happening as of today. Here's an example. So we have a working Pixel phone, just a broken screen, and you could buy it for around $25 and can start earning rewards by providing the compute to Accurist. These are evaluations that we did a couple of weeks ago. I'm really excited about them because this actually shows or proves the claims that we have made in the previous slides. This is pure execution time, so no latency included here, and it has been run for a couple hundred times over these different cloud services. So these were cloud functions compared with Accurist. And you can see already that we're beating them here below 3 seconds. Okay. I didn't do that. Good. Sorry. Didn't want to do that. Back to the right slide. So we're beating them already when it comes to execution time. And if you think about the pricing, which is already lower as well, that's quite remarkable. Also, we have to consider that we took random devices. So since we run this a couple hundred times, we took from our pool of processors, so these are all phones distributed around the world, we took randomly phones, and on average, they were still faster. Of course, that could also depend sometimes on the specific device that you're using, but compared with the cloud functions, it always ran faster. If you're a developer and you're wondering what did we benchmark, it was the generation of prime numbers. And the beauty of this is actually not just that it's faster, but for me what's really exciting is that we can actually prove with a signature and an attestation that this was executed on a specific device at a specific point in time, and then also returned to the executing developer, party, consumer. So it's actually end-to-end cryptographically verifiable, which is not the case with the other cloud functions. So what are you waiting for? Get your old phones out there and onboard yourself. So if you have an old Android phone, then you can just scan a QR code, onboard the device, and then start getting rewards from the Accurist Canary network. In the future, we'll support also other platforms, but we're very prone to keep it as secure as possible. So the hardware needs to provide certain standards and chips that can provide for example, HSM-like capabilities. So for example, the secure element in the newer phones, iPhones, would be an option as well. So yeah, stay tuned and looking forward to chatting to some people later. Thank you.